Hello, everybody, and welcome to week 13, week 12. We're on week 12. Time gets away from me. I'm glad it's not week 13. Anyways, week 12, which is on chapter 13, which is on indexes and constraints. So, indexes and constraints are actually, I think, probably something that you've already seen before, but you may just not have known it. Because I know we've covered it, maybe not in great detail. So, this time I hope that we can explain it really well and that it'll make sense to you. So I'm going to go a little backwards because I'm actually going to start with constraints and then we'll move into indexes. So constraints, as we have seen before, are, and like it says, are ways to constrain our database. And that might sound like a bad thing, but it's actually a good thing. And believe it or not, you've probably already used a constraint, whether you've known it or not, because anytime we create a primary key, we are automatically creating a constraint. Or if you've ever used the words not null when you create a table, you're creating a constraint. So let's talk about those constraints just a little bit more detailed. So, like I said, whenever we create a primary key, we automatically can create a constraint that basically says that it can't exist more than once. So that's a unique constraint and a unique index as well. So if we have this system user table, obviously we don't want two user IDs because our primary keys are the root of all truth, meaning that there's only one of them that exists in the table. That's what makes it the primary key. So those exist. Now, what I've done is I've actually created this table called system user. And actually, I don't think I've created it yet. So let's use my testing database. And we're going to create the system user table. Now, if we look at this, I have my user ID int primary key, which makes sense. Then I have an email, varchar, password, varchar as well. So pretty simple, nothing too crazy. So let's go ahead and create this table. And you'll notice that, like, realistically on email and password, I don't have any constraints, which we want to take care of. Let's keep going. So, and let's pretend that we do have some valid users. We have Frodo at the Shire. Oh, and you know what I forgot? Auto increment. Let's do that so we don't have to do that. So let's drop table system user and we will recreate it with the auto increments. We don't have to worry about it. So we add our users here. And so we have Frodo at theshire.com, Bilbo at theshire.com, and Gimli at fellowship.com. And all good and dandy. Now, let's say that this is in a production server and we have a place where users can register. We don't do anything, they can just sign up. Just put in your email, give us a password, and away you go. Well, let's say someone goes in here to sign up and they reuse Frodo at theshire.com. You'll notice that there's a new password. So if I were to run this, hey, it worked. And so if I say, let's select everything from system user, all of a sudden we have multiple Frodo at theshire.com, which could be a problem because, like, let's say I want to reset a password, or let's say that I use the email as a way to look up information. Obviously, you can see that there's some issues doing this because, maybe they'll share data, which obviously we would not want. So that's why we want to constrain our data. And another interesting use case is, let's say that someone wanted to just leave their password as null. They just didn't put anything in there, right? Technically, we can do that as well. And then we would have someone who has a password but no email. So obviously we want to constrain our databases. And what that does is it lets us know and make assumptions about our data that are going to help us basically keep everything clean, which is ultimately what we want, because we don't want bad data. And two, it also helps, security stuff, just like what we kind of went over. So what we would want to do is we would want to add a couple constraints here. The first one being, we want to make it so email and password cannot be null. Basically, when you create a system user, we want those to be there. And then secondly, we probably want to create a constraint on email to make it so it is unique. So I'm going to create a constraint here on the system user table. We're going to call it a user UQ1, and it is going to be unique, and it is going to be on email. All right, so I'm going to drop this table and we'll just start over because we'll want to see the differences here. So let's go ahead and create this table again. Make sure it got created. Perfect. So now I can go ahead and insert my stuff here. Now, when I try to do this one, you'll notice that I get this little red thing and it says error code, duplicate entry. It gives me the email, and then it says 4 keys system user UK1, meaning that, hey, this stopped me from creating a user with the same email, which might be nice because maybe Frodo forgot that he had an account already. We don't want 2 people with the same email because 2 people can't own the same email. So for that sake, we usually put unique on the email field. And so on and so forth. If we try to insert a record without an email, you'll see that we get an error that says column email cannot be null, which makes sense. We don't want a system user without an email. So that's a couple of examples of constraints. This one is a not null constraint. This is a unique constraint. Whenever you do a foreign key, believe it or not, you're also making a constraint. So let me actually just go into, let's say, customer. Actually, let's go into city. So if I take a look at the city table, and we go to, where is it? Foreign keys. Well, actually, let's do this. If I right click on city and go to copy to clipboard, let's do the create statement. We'll just take a look at it here. So if we wanted to see how this was made, we can see right here that there's this constraint called foreign key city country, and it's a foreign key and it references country. And you'll notice that this constraint, basically what this is saying is that if I put something in country ID, it has to exist in the country ID table. And we've gone over foreign keys before, so I don't want to go too in depth, but just know that whenever you create a foreign key, you're creating a constraint, meaning that it has to exist. Now, that doesn't mean that it has to be not null, meaning that, oh, I can create a foreign key and leave it null and it doesn't check. But if you create a foreign key, it has to, if you put a value in for it, it has to be there. So that's another example of a constraint. All right, so that's kind of constraints in a nutshell. And I'm going to try to move a little fast, especially on those ones because we've been there before. And I kind of want to get to some of our other stuff. So the next thing that I want to go over is indexes. And indexes are one of those really cool things that you don't really think about, but can make a big difference. Maybe not for us right now, but as you get to use more data, they can be very helpful. So you can imagine back in the day, maybe you've seen this before. You've probably seen the old cabinets, but libraries back in the day, before computers, if you wanted to find a book, you had to use an index. And there was a lot of fuss in the library and data world before computers about indexing systems, which is really fascinating. If you want to go look, take a look at Wikipedia. It's really cool. Indexes, library and cataloging. Lots of different theories. But if you think about it, before computers, if you went into a big library and you wanted to, say, find a certain book, there's a few different ways you could go about it. You might know the name of the book, you might know the author, you might be looking by category, but the way they organize the library could vary. Like, for example, like Barnes and Noble, they organize by category, then by author, and so on and so forth. But what librarians would do is they would build indexes, and you could have multiple indexing cabinets that would help you find the row, the shelf number of where the book was in the library. So, for example, if we wanted to look by author, there would be one cabinet where you could go find the last alphabet name of the author, pull it, find the book you're looking for, find the author you're looking for, and then find the book within that, like they'd be little cards, and then you could, locate the shelf of where this book was. Same thing if you were looking, let's say by reading level, right? In the bigger libraries, by reading level, there might have been another index to find books by reading level, or similar. And indexes in our databases work the same way. And essentially, what they're going to do is they're going to make finding pieces of data faster and easier for the computer. And we're actually going to go over that here real quick, because even with our little data, we can see the results. So in our customer table, we have an email field. And I wrote this little query that says select everything from customer where email is equal to kcaldwell@movies.com. Now, our databases is really small, but you imagine we're Facebook or something like that, and we're looking for a specific user account by email. Now, if we wanted to find that faster, there's some logical things that we can do to make this easier. And I think mentally we do this all the time, and they've built algorithms on the computer that will do this, and all we have to do is tell the computer to do it. Then there's pros and cons, which we'll go over. But imagine that we're Facebook and we're looking for one account based on email, just like this. We're looking for our account where the email is equal to k.caldwell@movies.com. Well, what we could do is if we had an index, meaning that, I know that the K's, emails that start with the letter K, start at row 2 million. I could skip the first 2 million rows, and I don't even have to bother with those, if that makes sense. Or if I'm the database, I could cut the database into sections of even 4 and know exactly which quadrant this is going to exist in to cut my result size down by 3/4. Because then instead of looking at 3/4 or 100% of the data, now I'm looking at 25% of the data, which is going to improve performance of the server, meaning that I don't have to load all this data into memory to search it. And B, it's going to make it faster because I don't have to evaluate every row in the table. So let's take a look at this. So what I'm going to do is, I don't believe I have this index on. Yep, so I don't have this index on. So on the customer table, as of right now, there isn't an index for email. You'll notice that we have an index for store ID, address, and last name, and obviously our primary key. But we don't have one for the email column. So I'm going to go ahead and I'm going to run this in the terminal. And the reason I run this in the terminal is because these explain and analyze commands only work in the terminal. Let's use Sequila. Then try it. All right, so we can see here there's some information. And let's run 2. So we did explain, analyze. Let's actually do just an explain as well. All right, so from this output, we can kind of look at this and see what's going on. So explain is going to tell us kind of how it's doing it. So it's a simple select type on the table customer. You can see that our possible keys is none and 599 rows, filtered 10, and we use the where clause. So the extra kind of explains why it does what it does. It's using the where clause to filter. And it says filter, customer email is equal to this, and the cost was 61.15. Row 60 actual time. We have our actual time there. It looped 1. Anyway, so there's our cost and information like that. All right, and there's our rows, 599, 600. Anyways, so what I'm going to do is we can kind of see that. What I'm going to do is I'm going to actually create this constraint. And what it's going to do is it's going to create a unique index, just like we did before on our customer email address. So let's go ahead and run that. Let's see. Oh, we are on secure. Let's do that. There we go. So let's create our index. So now we have an index on that email column. So let's go back here and we're going to run our first one. And I can tell you it's already looking better. And then let's run just our plain explain so we can compare the results. So if we look at our first prior, you can see that we had a cost of 61.15. And the cost is kind of this estimate of how much power did that take the database to perform. And then obviously our time and our rows. So basically it spent 61.15 of database power to evaluate 60 rows, meaning that it had to loop through 60 rows or it had to read 60 rows and evaluate it. And it took 0.7 seconds. If we look at after we have the index, our cost is 0, right? I mean, small enough that it doesn't register. Rows is 1. It actually didn't even have to look. It knew exactly where it was. Now, this is probably just because our data size is really small, but it just goes to show you how much more efficient it is. So when you are the next Facebook, it's going to be massive how much improvement it is. And then if we look at our actual time, it again is non-existent, which is pretty cool. And then let's compare our analyzer. We can kind of see what's happening here. So again, simple customer table, no partitions. The type is a constant, and it is using the customer unique one key that we built. So there's the possible keys. This is the key it used. The key length is 203. A reference is constant, meaning that it located it for, straight. It didn't have to like partition the data. It just knew right where it was. It evaluated one row and filtered 100 out. So it didn't even have to evaluate 100 rows, essentially. So anyways, pretty cool. So that's what those indexes do. And you can create indexes on one column, multiple columns. But that doesn't, and so a lot of people say, well, let's just put an index on everything, which is the wrong approach. And the reason why is anytime we create an index, basically what we're doing, just like those filing cabinets, this is how I like to think about it. Whenever a library created an index, they had to go buy a filing cabinet and have it somewhere in that library. And someone had to go through all the effort to create that index system. Now, computers can create the index system pretty readily, but where it becomes expensive is in maintaining those indexes, as well as storage space on your server. So there's a handoff. You get faster queries at the expense of, well, every time, because you can imagine, like if you're Facebook and you have, let's say you have 1,000 people sign up every day. Well, the computer has to continually maintain those indexes. The database does. It has to continually maintain those indexes, which is costly in performance of itself. And then also it takes up storage, because every time it creates that index, it actually creates like hidden tables that we don't see where it manages all this data, which takes up storage space. So it's kind of twofold. So kind of the rule of thumb is you want to evaluate and say, hey, and that's why we have tools like explain and analyze. If I create this index, is the cost going to be worth the speed on the other side? So rule of thumb is if it's something that you use frequently to identify a row, if it's constantly in the where clause, you might want to index it because it's going to help make your database faster. So something like email is something that we're probably going to use frequently. And there might be many things you want to index. Facebook, for example, you probably wouldn't want to index a post title, for example, but you might want to index people's usernames because people want to search for usernames. Or, if you're LinkedIn, you probably want to index your company names because that's what people search for. And so that the cost is going to be outweighed by the performance when people are using your platform. So anyway, something to think about. Indexes are really cool. They're also kind of this deep, dark mystery of how they work. So I try to keep it broad. But anyways, I hope that helps make sense. So finally, what I'd like to do just a little bit is go over a couple of the examples or exercises from the weekly exercise, specifically the vehicle questions, because they can just be a little confusing. Because like I said, so far what we've done is we've created a unique index on one column, but there's a couple times in the, I think one question in the example where we create a unique index on 2 columns combined. So let's go ahead and do that. So I'm going to go ahead and use my testing database. And I have this vehicle table, and I think I've already created it. Let's check. Nope, I haven't. So I'm going to create this vehicle table that they kind of reference in the questions. Now I have make model ID in here just to kind of make it relevant, but they actually don't connect to anything. Because really what the questions apply to are this vehicle ID and this VIN. So question 4 of the exercise says, assume you have a vehicle table with a surrogate key vehicle ID column. And the surrogate key means, like, you know, it helps you find this stuff fast. And then in there we have a VIN number as well. So anyways, let's so we have our VIN number and some other columns, and we want to designate a unique index on the VIN column because it has the highest cardinality or degree of uniqueness. So basically what it's saying, since vehicle ID, I mean, right here I have it defined as my primary key, but let's pretend it's a surrogate key, which essentially might mean the same thing. But basically, just like our email, a vehicle identification number wouldn't make a lot of sense if multiple vehicles had the same identification number. So what we want to do is we want to create a unique index on that VIN number. Even though we already have a vehicle ID, we want to create this index on A because it's going to constrain our database, meaning that 2 VINs can exist, which is something we want. But also because it's a unique index, the database is going to be that much more efficient at finding the vehicle based on the VIN. And just to reiterate, the reason it can do that is A, because the computer is going to index it, but also because it's a unique index. Once it finds a match, it can stop looking because it knows only one exists. So that's why it's a little bit faster. So how we do that is we say create unique index, and we give the index name on, and then we have the table, and then in parentheses the column within that table. So basically we're creating a unique index called vehicle UQ on vehicle.vin, right? Pretty simple. So let's go ahead and run that, and bam, now we have a unique index on our VIN number. So that's question 4. So it has a lot more words, but I wouldn't let it confuse you so much. All right, and then question 5 says, assume you have a vehicle table with a surrogate key vehicle ID column and a VIN, vehicle identification number column, and some other columns. You want to designate a unique index on the vehicle ID and VIN columns because together they filter on the joining column with the highest cardinality or degree of uniqueness. So basically, sometimes in our databases, we want to do joins on 2 columns because maybe it's not always a one key primary foreign key. So a good example might be if we want, let's say that we have a database and we want to join 2 things together, like let's say based on a street address and a zip code, because most of the time you're not going to have 2 same street names in the same zip code, because I mean, I don't know if that can happen or not, but let's just say it's a thing. So then when we do our join, we would want to join on both of those. Well, essentially that's what we're going to do here. So we have a vehicle ID and a VIN number. We want to find based on both. So whether we're doing a join or a where clause, to get to a unique vehicle, we need a vehicle ID and a VIN number. So what we're going to do is we're going to create a unique index using 2 columns instead of just 1. And we do it the same way. Create unique index, vehicle, give it a name, on vehicle table. So this is the table name. And then in parentheses, we can just put multiple columns here separated by a comma. Okay, so in this case, the index is actually on a combination of these 2. And it's pretty easy to think about it just as being like concatenate the 2 values together. And that's unique, if that makes sense. So for example, if we were going to say like, oh, we want to join on, make unique index on city and state, you know, I could do Salt Lake, you know, let's say our city is Salt Lake City, and the state is Utah, you know, we can just kind of plug those together. So that way, if someone wanted to say, like, oh, Salt Lake City, Nevada, you know, not a problem. It's still unique. Someone could do Provo, Utah, and it's still unique. But if someone tries to do Salt Lake City, Utah again, it's unique. So that's basically the 2-column things. If you think about it, just plug them together and see if they match. So let's go ahead and run this. Bam, we've got a vehicle table with a unique index on the vehicle ID and the VIN. All right. So anyways, questions 4 and 5 seem a little bit more complicated than what they actually are, but they're actually quite simple. There's just, you know, more to it than they explain it in a very smart way, if that makes sense. But anyways, that's actually all I had. I hope this helps explain a little bit about indexes and constraints. And I hope that even though like it's probably a little too late to put them in your final projects, but something to remember. And there's a reason that we cover these later, and that's because, you know, they're nice to haves, not must haves until you get big. Once you get big, you probably got to have them. But for our projects right now, not so much. But if you ever get bored, feel free to add them. But anyways, if you have anything come up, need any help, feel free to let me know. Otherwise, have a great week.